Hello, guys. Hope you are doing well. Welcome to CFD College. I'm Ashkan, and we would like to continue our course on post processing in CFD Post. Uh, Welcome to this course, and I hope you enjoyed previous tutorials and previous videos on this course and other courses that we have. Before starting the video, uh, I would like to ask you if you find these videos useful, please share these videos with your friends. Please like the videos, and also if you don't want to miss uh, our future video, uh, subscribe to channel, and you can contact us using our contact info. You can find them in channel description. And let's get started this tutorial. In this session, I'm going to show you how you can generate streamlines in 2 and 3 dimensional domains of your CFD results. You can use streamlines to study, to examine, and to show the flow field in your CFD domains. In this video, I will show you how you can do it. First, we start with this the two-dimensional simulation, as you know. Uh, in two-dimensional domains, uh, creating streamlines are so easy and it's not challenging. You can generate streamlines using this icon, using this option, streamline, and you can uh, find it here under the insert tab. You can see here we have streamline. So if I click on this, by choosing that, you can specify a name for it. I continue with the default name. Here you can see that we have some details here by which we can modify the plot, actually the streamlines view. Uh, we have view and render tabs, limits, symbol, color, and geometry. We usually work with symbol tab and geometry. You can also change the coloring. Let's review them by one. We have two-dimensional CFD result. As you can see here, we have two types of streamlines in CFD Post. You can't see these options in other software, for example, in TechPlot. But here in CFD Post, you can create either 3D streamline or surface streamlines. Since we are working in two-dimensional domain, we should use surface streamline. You can also use 3D streamline in two-dimensional domain, but uh, we have better control on streamlines if we use surface streamline. And it's a good practice because sometimes in three-dimensional domains we want to use surface streamline. So in this example, which is a two-dimensional domain, I show you how you can use and how you can generate surface streamlines. And in three-dimensional domain that we have, in a few minutes, we work with 3D streamline. So I select surface streamline. You can see the options have changed. So we have to select a surface. Since we are working in 2D, So we have to choose symmetry 1 or symmetry 2. There is no difference. If you wanna generate 3D streamline, you have to choose, for example, inlet or outlet or other, planes or lines. But in two-dimensional simulation, uh, when you wanna generate surface streamline, you have to choose symmetry 1, not inlet or outlet. Okay, so uh, let me choose symmetry 1 and then I click on apply to see what we have. Here you can see we have a few streamlines. That is because the number of points are 25, which is a low value. This is a small value. You can change the start from option. Here we have equally spaced samples. You can select the vertices, face centers. If you have seen our previous video, you know what are these options are. You can also choose a locations, for example, inlet, uh, or any other, if you have any other lines. Uh, pro- mm, so let's choose equally spaced samples first, and then increase the number of points. Now you can see we have more streamlines. Here in a variable, you can select velocity or wall shear. We mostly actually use velocity as a variable. Here, the direction is uh, forward and backward. You can select either forward or backward. For example, you can generate a line at this section, and then you can, you know, uh, show the streamlines that start from this line. If you want to do that, you have to change it the direction to forward. And the backward is the opposite. For example, if you have a line here and you want to see the streamlines that are reached to this line, you have to choose backward. But if you want to see the general view of streamlines, you can select forward and backward. So this is uh, where the representation of streamlines when you use quality space samples. As I mentioned, you have other options. You can change it to vertices. You know what are these options? What these options are. So let me increase the maximum number of points. Here you can see we have a greater number of streamlines near the cylinder. That's because and in these regions the grid is finer. This is the benefit of vertices option. You can change it to any location. For example, inlet. Now the streamlines are started from the begin from inlet. But you have to play with these options to get the best view. Uh, for example, you can select this option and then you can create a line behind this cylinder and generate some streamlines past the line. For example, let me do that. Generate line. Mm, the first point is 1, 1, 0, and 1, -1, 0. You can specify the number of samples. 10 is okay for me. Let me, yes, you can see this is the line. So let me change the position of this line. It's too much. So 1.5. It's okay. And now you can create another streamline. So you can have multiple streamlines. You can combine them to get the best representation of the flow field. I change the type to surface streamline, and then symmetry 1, locations, line 1, and I change the maximum number of points to 10. Here you can see these are the streamlines that are passing this line. Let me change it to forward. See the streamlines that are started from this line and go towards the outlet are showing to us. Uh, so I think we need some line here, or we can change the direction of line 1, for example, 0.5 and 2.5. Now you can see we have an inclined line, and we can see the vortex or the vortex here and another vortex here. So you can change the uh, coordinates of the line. You can add different streamlines to get the best view of your flow field. What else we can do? Let me deactivate the second streamline and the line 1, and okay. If you go to the color tab, you can change the coloring of these streamlines. They are now colored by the velocity, the plot variable. You can change the variable, for example, to pressure, or you can specify a constant color. You can combine the streamlines with a contour, so you can generate a contour. For example, contour of velocity. You know how you can do it if you have seen the our previous videos. So let me increase the number of contours to have a smooth contour, and then you can increase the transparency to 0.5 here, or even 0.8, 0.6. Now you have both streamlines and a contour. Uh, you can change the symbol. Now these are lines. Maybe it's better to choose tube. Okay, we have to uh, reduce the tube width. Let me deactivate contour and change the coloring to use plot variable, and increase the tube width here. Now you can see the streamlines are not just lines, they are in the shape of tube. You can increase the size, for example, to 20 if you want to see or have the better view. It's something like what we can get in ParaView. Of course, I think ParaView can show the streamline better than CFD Post, but you can play with these, options. Mm, and I think it's okay for 2D sample. Let's go to a 3D one. This is the a 3D simulation. You know that we have an inlet here, and here is the outlet. The flow has a swirl, so it's good to show the flow field using streamlines. Uh, I add a streamline function, and now I will work with the 3D streamlines because I want to see the streamline lines in my three-dimensional domain. I don't want to see them uh, on just a surface or on a plane. So leave the type. It should be 3D streamline, and then you can select the start from location. It is mainly, usually we use inlet because we want to have the streamlines from inlet towards the outlet. So I choose inlet. Uh, Let's see what we get. Let me show the domain. Uh, so I have to select these and then change the transparency to 0.8. 0.8. Now you can see the domain and the streamlines. You can see the rotation of the flow using the streamline. You can increase the number of streamlines. You can change the sampling option, for example, from vertex. Now, you can see we have a lot of streamlines. So let me decrease it a bit. You can change the symbol to 2, and I think 0.2 is good. You can change the coloring, but here in 3D domain, we cannot add, contour of velocity or pressure. So it's better to color to use the coloring for use the color for our streamlines. Uh, let's see what we have. Okay, if you see there is no streamline at these areas because here we have a vortex tube, and the streamlines that are in this region, they are not originated from the inlet. So we have to create a line or a plane and add another streamline if you want to see the streamline in these regions. So let's create uh, an ISO surface. It's easy. Uh, X in X direction, and I should specify the value of X equal to 0.35. See? The location of this ISO surface is good. So we have to add another streamline, and we have to select isosurface 1. We need actually we want to start. We want to see these streamlines that are passed through this isosurface. And remember, you have to change this, or you can leave it here in this way. No, the direction can be forward, and you can apply and see what you have. And then you can change it to forward and backward. These are streamlines. Yeah, maybe it's better to decrease the number of points because here the streamlines are rotating. And now let's change it to forward and backward. Oh, this is good. Now you can see the full view of the streamlines. You can decrease the number of points. If you have some periodics boundary and surfaces in your domain, you have to check this option, cross periodics. Here we don't have any periodic boundary, so it's not important in our case. You can change the symbol to tube and decrease the tube width. Uh, and let's play with limits. Here the streamlines are in blue because the velocity is low in this region. Of course, you can change it, I think, to local. No, yeah, because the velocity uh, here is higher. Okay, let's go to limits. Step tolerance. Here you can, modify the length of these streamlines. You can select absolute or grid relative. For example, in absolute, let's choose 0.5. Yeah, now you have nothing. So let's increase it to 0.5. Okay, let's use grid relative and then decrease it to 0.005. See, by increasing this value to, for example, 0.1, I think 0.1 is the default. You can uh, change the length of these streamlines. If you have a lot of streamlines, you have two options. You can play with this option, or you can reduce or decrease the number of points. Uh, Here we have mm, a steady state simulation. Uh, and you can also play with maximum segments. You can decrease it or you can increase it. For example, if I change it to 1000, here you can see the length of each streamline is reduced. So you can increase it or decrease it in a way that you have the best view. I think it's too low, so I will increase it to 5000. Now it's better. And you can change the transparency. The render and view tabs are almost everywhere in every function in CFD Post. Uh, but this is what I wanted to say about these streamlines. Okay, before uh, finishing and ending the video, let's have, for example, if you wanna uh, see the streamlines on, for example, the middle plane of your geometry. Let me create an isosurface, uh, y direction, and 0 is okay. Here you can see the middle plane, the mid plane of your domain, and if you wanna see the streamlines on this isosurface, on this plane, on this section, you can create a surface streamline on this isosurface in 3D simulation. Now, if you see, let me deselect the isosurface, or now here you can see the streamlines on this isosurface. You can increase the number of lines, and you can reduce these limits, these options to have a good view at these areas. Oh, 2000. I think it's good. Uh, and so if you want to have the streamlines on a certain plane or cross-sectional plane in your three-dimensional domain, you can use surface streamline, but you have to create the plane or the isosurface first. And you can, for example, show the pressure or velocity or temperature contour, and you can have the streamlined over it. So you can use the different combinations of streamlines, vectors, and so on. 0.6. You can have, for example, pressure contour, and here the velocity streamlines. Mm, or you can change it to velocity vector, velocity contour, and then you can change the color of the streamlines. Now you have both contour uh, and the streamlines, just like what we did using contour and velocity vectors in previous video. So I think that's enough for this tutorial. Please like the video. I hope these videos can help you, and I really like to know you. So if you have any comments, if you have any question, you can email us. You can contact me in Telegram or by email. Uh, or you can just write down your comment or your question in the comment section. I will answer your question. Please subscribe to the channel. Don't forget to share these videos with your friends. And until the next uh, video, uh, be safe. Thanks for watching the video. Bye bye.